Hey, good morning, guys and gals. Mr. Herr here. Hopefully, everybody's healthy, wealthy, and wise on your end. Today, ladies and gentlemen, we're going to continue with the PERT equation, aka the continuously compounded um, interest equation, and how that applies to real world problems. It's only two examples in our notes, and it's really not that many problems in our homework either. So I'm hopeful that it will go pretty smoothly for us today. Yeah. So without further ado, let's do this thing. Watch out for the spring. Um, as always, perfect time to pause the video, grab yourself a pencil, piece of paper, all that good stuff. Okay. Just a little bit of a review because I touched on this yesterday, but I probably didn't go over it quite enough. Okay. When we're talking about continuously compounded interest, we have our account balance, we have the principal, which that's what we start with. We have the base E, that never changes. We have our rate, which is a percentage converted to a decimal, and our time, which is always in years. And notice the rate and the time, these are exponents here of our E, base E part of the equation. So you opened a 401k account with $8,000, averaging an 11% return. That's unbelievable. You never see that in the real world, but hey, a guy can dream, right? Compounded continuously. If you left that money in the account for 25 years, what would your new balance be? So we have $8,000 times E to the power of 11 hundredths times 25. I'm not you, mostly because I'm old and senile. I don't know if I've ever mentioned that before, but I would definitely multiply that first. So I do that before I type it into my calculator. Well, 0.11 times 25, that gives me 2.75. So if you're using your cell phone calculators, you'll take 2.75, press the E to the X button, times $8,000. When you do that, man, do you end up with a lot of money. It's $125,141.06. Okay? That is awesome. Awesome, awesome. Okay. Now, for the record, you never see an 11% return that's continuously compounded. You might make 11% in one year and then 6% the next, vice versa, but it's really hard to sort of plan that out for years and years to come. Okay. Number two, a little more difficult. You opened a 403b account that has a 9% return compounded continuously. You left that money in the account for 15 years. What would your principal be if you want to end with $30,000 after 15 years? Okay, we haven't seen this yet, so we want to end with $30,000. So I'm going to take 30,000 equals the unknown principal. I don't know what that is. I'm just using the variable p times our base E. That's to the rate of 0.09 times 15. Okay, the quick math tells us that is 30,000 equals P times E to the 1.35 power. Okay. Now you can do this however you would like. You can type it in ahead of time and then round. I would highly recommend though, this, believe it or not, is one term because it's the base E. Remember, that's like 2.718 blah, 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 to the 1.35 power. So we can actually divide both sides by e to the 1.35 power. And you might say to yourself, well, Mr. Herr, why would we do that? When we do that, the e to the 1.35 here on the right-hand side, they cancel. We're left with our principal. The principal is $30,000 divided by e to the 1.35 power. You can type that in your calculator. Sure enough, if you want to end up with $30,000 after 15 years, you have to invest, sorry about the bad sevens, $7,777.21. At that rate, you'll end up with $30,000 after 15 years. Okay. I know this one in particular is the tough one, so maybe rewatch that one because you'll see some of those principal questions on our homework. All right, hope that helps. Other than that, peace.